Welcome back to The Explainer. I am so thrilled you're joining us today because we're going to unpack something absolutely wild. Imagine holding a tiny pocket-sized rectangle, and right before your eyes, in one continuous fluid motion, it transforms into complex, heavy machinery. It literally looks like movie magic, but spoiler alert, it's not. It is pure, rigorous engineering. Today we're diving deep into exactly how complex miniature mechanisms operate. We're going to watch this compact little block unfold into a highly intricate machine and break down the incredible science making it happen. So grab your mental magnifying glasses and let's get into it.
Right off the bat, we're looking at a massive spatial geometry puzzle. I mean, think about it. How do you hide a fully functional bulldozer inside a pocket-sized rectangle without completely breaking the laws of physics? The constraints here are just mind-boggling. There's no impossible expansion, no CGI hiding extra parts off camera. Every single gear, every track, every hydraulic arm has to already exist, packed tightly inside that dormant little block. It's an absolute engineering marvel. And today we're going to see exactly how they pull off this miniature metamorphosis.
Okay, let's dive into the blueprint for this transformation. First, we'll look at the mechanical catalyst. Then, deploying the miniature track assemblies. Third, extending the hydraulic blade systems. Fourth, elevating the operator cabin. And finally, number 5, believable proportions and realism.
All right, Section 1, the mechanical catalyst, initiating the transformation.
Picture this, a perfectly steady shot. This unassuming rectangular toy is just sitting quietly on a rugged steel workshop table. A thumb presses down on a clearly visible black safety button, framed by this bright yellow protective ring, and then a crisp mechanical click is heard. That one single sound is the starting gun, right? It releases all that stored potential energy and sets the entire metamorphosis into motion. Literally a split second after that click, the tension breaks, and we get this brilliant sequential breakdown. Step 1. The internal locking pins instantly retract. Step 2. The dormant rectangular shell actually begins to separate along these beautifully tight precision machine seams. And then Step 3. The side armor panels rotate outward on heavy-duty hinges. Just like that, the tightly sealed box is officially open, and those incredibly dense, compact internal mechanisms are finally exposed to the light. Once those armor panels swing open, let's just pause for a second to define what we're actually looking at here. The exposed interior is this dense, crazy forest of compact gear trains, rotating shafts, miniature drive mechanisms, and springs. What this brilliantly illustrates is the use of cams. Now, cams are basically rotating or sliding pieces in a mechanical linkage used to transform rotary motion into linear motion, a concept that actually dates all the way back to the Hellenistic period, which is wild. These are the macro-level mechanical drivers physically pushing the internal chassis to extend, perfectly maintaining the realistic proportions of the original handheld toy.
Moving right along to Section 2, deploying miniature track assemblies, foundation of the bulldozer.
Honestly, this is probably the most visually satisfying part of the whole metamorphosis. From these concealed compartments in the lower side sections, compact track assemblies just emerge. First, the track frames telescope outward. Then, they rotate downward into their true operating position. And here is the absolute genius part. The individual track lengths unfold from tightly nested segments that were already stored within the body. They wrap naturally around the front and rear drive wheels until the completed tracks lock securely into place.
The crucial point to take away here is the kinetic language of the machine. The completed tracks lock with satisfying metallic clicks and realistic tension. You know, it's not just about things looking like they're moving. It's about actual physics. When those unspooled tracks wrap around the drive wheels, they don't just hang there loose like cheap plastic. No way. They lock into place with perfect, realistic tension, firmly grounding the miniature bulldozer to that steel table.
Which brings us to Section 3, extending hydraulic blade systems, the front housing metamorphosis. Let's see how this front housing builds out. Layered mechanical arms push forward on reinforced sliding rails. As they push out, these hydraulic-style cylinders actually unfold from within nested components. And watch closely how the blade itself forms. Multiple overlapping steel panels, which are already integrated into the outer shell, slide together to assemble a wide, heavy-duty bulldozer blade. It pivots upward, lowers smoothly right into its working position, and locks firmly. So, what's the secret behind that robust blade extension? Telescoping guide rails. Think of it kind of like a heavy-duty camera tripod, where nested, tubular, or channeled structures slide within one another. They allow the internal chassis to extend its reach outward to support those heavy hydraulic-style cylinders and the wide blade without ever compromising the structural integrity of the tiny toy. It's just a brilliant way to expand the footprint while sticking strictly to physical constraints.
Now for Section 4, elevating the operator cabin, completing the upper structure. The choreography here is incredibly precise. Beneath the chassis, compact rear stabilizing components unfold just to balance the weight. Then, right from the very center, the operator's cabin actually rises up through another telescoping support mechanism. And it doesn't stop there. These tiny micro details come to life. Protective roll bars rotate upward into place, tiny transparent windows elegantly slide into position, and, my personal favorite, a small exhaust stack extends perfectly from a concealed slot.
Finally, Section 5. Believable proportions and realism, the rule of conservation.
Now, what's really fascinating here is the strict structural mapping. Every massive component of this bulldozer has a specific origin point mapped directly to the original shell. Look at this. The tracks were hidden in the lower side sections, the blade and hydraulics were nested in the front housing, the cabin and stabilizers tucked right into the rear center. No new parts magically appear out of thin air. Every single piece originates entirely from the existing block.
This comparison perfectly highlights the incredible contrast of the metamorphosis. In its initial state, it's totally dormant, just nested structural rails and concealed compartments. But look at the final state. It is intensely kinetic. Exposed gears are continuously turning. Miniature drive shafts are spinning. Springs that were once compressed are now released. And every single hinge and articulated linkage is engaged with totally believable engineering.
That final idling state is an absolute masterclass in premium industrial craftsmanship and cinematic realism. The bulldozer settles firmly onto its fully deployed tracks. The tracks rotate slowly for just a brief moment, kind of like they're testing their movement, before stopping. The front blade raises and lowers smoothly through its articulated linkages. The cabin even gives off this subtle vibration, mimicking a running engine. Tiny warning lights glow softly near the rear, and those exposed gears just keep turning behind the transparent inspection windows. It's literally a living machine.
It just leaves you in awe of what's mechanically possible right within the palm of your hand. Which brings us to our final thought for this explainer. If precision engineering can build a completely physically believable metamorphosis in miniature without a single camera trick, what other everyday objects are hiding extraordinary mechanical secrets just waiting for a single satisfying click to unfold? Keep exploring, keep questioning how things work, and we'll see you in the next explainer.